Now, in the previous session, we looked at angle between two lines given 2 points. So, since only 2 points were given, we took the position vectors of those 2 points and we figured out the angle between those two position vectors. Now, let's actually look at the angle between lines when 2 or 4 points are given. So, one thing we know is we would require the unit vectors. So let's first define off that unit vectors I, j and k, 0, 0, 1. Okay. Now let's say we have a1, b1, c1, a point with 3 coordinates, right? So it will automatically create the sliders. Similarly, let's say we have a2, b2, c2, right? Okay. So and since all the values are same, that is why it is there one on top of the other. So let's move it so that they are away from each other. Now let's specify let's connect these 2 points, a comma b. Okay. Now let's create 2 more points, a segment between 2 more points. So let's say a3 comma b3 comma c3, and similarly a fourth point, a4 b4 c4, and again let's move them around. Okay, let's move this around. Let's move this around. Okay, now let's connect these 2 points. So segment c comma d. Now what we have to do is figure out the angle between these two lines. Now if you move this, you will realize that they are not actually intersecting. They are away from each other. So what do we do in such a case? Let's see. So first of all, let's figure out the DRs, direction ratios of these two lines. So A2 minus A1, B2 minus B1, C2 minus C1, right? So this is direction ratios of line AB. Okay. Now similarly, let's look at the direction ratios of the other line, CD. So that would be A4 minus A3, B4 minus B3, and C4 minus C3. Okay. Now let's treat them as vectors. Right. So A2 minus A1, that is A times the unit vector I, plus B times J, plus C times K, right? And these unit vectors, we don't really need to show it on the diagram, so I'll just hide them. Now if you notice, these two lines are parallel to each other. AB and this vector, they are parallel. Now similarly, let's do it for the other line. So by doing this, basically what we are doing is we are making or moving the line AB to to begin from origin. The direction of the vector itself doesn't matter to us. Okay, so let's do the other one. So that would be D, A4 minus A3 times I, plus E, B4 minus B3 times J, plus C4 minus C3, that is H times K. And now if you see, AB and this vector are parallel, and these two vectors are parallel, CD and vector V. Now these vectors start from the origin. So now it's easy for us to figure out the angle between these two vectors, and that would be the angle between those two lines. Okay, so first of all we require the magnitude, and remember GeoGebra itself provides us a function to calculate the uh, magnitude, and when we create a segment G is equal to segment C comma D, it automatically gives us the length. So we can use G, but let's actually use the formulas that we uh, have learnt. So let's say P is equal to square root of, remember magnitude is square root of A square plus B square plus C square. And similarly, let's say Q is equal to square root of uh, D square plus E square plus H square. So this is the magnitudes of the two lines. Once we have this, we can figure out the angle between these two lines. What is that? Theta is equal to cos inverse. So the function is arc cos. So A cos of A times D, that is the corresponding direction ratios, plus B times E plus C times H. Okay, and now let's put this in a bracket and let's divide this by the product of the magnitude. So P times Q. So that gives us 97.33 degrees, right? Now GeoGebra itself gives us a function angle between U, vector U and V. So that is also 97.33. Yeah, maybe internally it is using the same formulas for calculating the angle, right? Now, of course, when you see intersecting lines, it is not just one single angle, right? You have one angle, so vertically opposite angles, and the other angle, the second pair of vertically opposite angles. So that would be what? 180 minus 97.33, the supplementary angle. So that is angle between two lines in 3 dimensions. Bye.